Hello, I'm Joe McCarthy, Senior Technical Marketing Engineer for Steel Central. This video will show you how using Steel Central's suite of tools, you can quickly troubleshoot Avaya UC issues by combining both network and UC metrics to identify call quality issues. To begin the troubleshooting, the NOC operator selects UC Avaya from the Steel Central portal. The NOC operator notices that call experience by group and media quality are taking a serious hit, a lot of red on the views. So to investigate further, I'll simply right-click, launch, and troubleshoot media. In the troubleshooting view, we're looking at all the media streams, and you can filter this data based on your specific needs. I want the poor ratings to bubble up, so I'll go to the ratings column and simply click on it, and it refilters to fair. One more click, and now I'm seeing all the poor calls. To troubleshoot deeper, I'll select one of the poor calls and then go to Path Analysis. In this view, we see the actual path that the media is taken through all the different switches and routers all the way to the endpoint. We notice on this router, the DSCP marking going in was EF, expedite forward as it should be for a high bandwidth type application, and jitter and packet loss are looking fine. But when it exits this router, that DSCP marking changed to default, and that's an issue. When we select the default DSCP marking, notice that jitter and packet loss still are looking fine, so we still need to do some more troubleshooting. When I select the final DSCP marking at the endpoint, I notice that packet loss and jitter jump dramatically. Jitter is now above 30 milliseconds, while packet loss is at 40%. So certainly we understand where the issue is beginning. Before it went in, jitter and packet loss are fine. At the endpoint, now we can see where the call quality has gone south. I also noticed this router is red. So when I select the router, we even get information about how it's doing. And we can see that the CPU is near 100%, memory is very high, and response time metrics are very high, as compared to the router just in front of it, where the metrics look normal. So we can see when the tag was changed from EF to default, this router went into trouble. This interface within this router, when we click on this interface, we can see that the class of service for the default queue, the default DSCP marking, is completely pegged or saturated at 100%. So now we know what has happened. In this router R01-SW, when the EF marking came in, it changed to default. Now the default interface on this router is not set up or configured to handle high bandwidth traffic. It's meant for default basic type traffic. So now we need to contact IT, let them know that router R01-SW needs to have a configuration change and make sure that the EF tag holds true all the way through. After the configuration changes have been made, the operator can test this path by using a feature unique to Riverbed called Remote Hands. This feature provides fully automated testing capabilities that remotely instructs endpoints to place and receive calls, and can perform more complex multi-party functions such as conference and transfer. To use Remote Hands, select the call of interest and then select Remote Hands. The two handsets will appear, and select the line you want to activate, which will be this top one. I'll select this LED. That line is now active. Now I'll type in the extension I want to dial, which will be 3004. Then hit the green arrow to send the call. On the far end, you'll see the blinking red LED. To accept the call, simply click on that LED. And now the call is accepted. To end the call, click on the speaker icon, and that will kill the call. By proactively monitoring the UC traffic with Riverbed Steel Central, a NOC operator was able to identify there are ongoing call quality issues, isolate the issues down to a specific call stream, and determine the cause of the problem was a configuration issue with a router changing the DSCP tag from EF to default. This in turn caused high bandwidth traffic to go through an interface which was not configured to handle this level of traffic, which in turn caused jitter and packet loss to increase dramatically, and spiking the router CPU and memory, ultimately causing poor call quality for anyone using this path. Thanks for watching. For more information on Steel Central UCExpert, please visit the link below. Thank you.